Good afternoon. I'm Pranav Swarup and from SVC College of Engineering, and today we'll be talking about fiber channel technology. In today's video, we'll talk about what a fiber channel is, and we'll talk about fiber channel layers and the fiber channel components, as well as the fiber channel design and configuration. So, what is a fiber channel? Fiber channel is a high-speed networking technology primarily used for transmitting data among data centers, computer servers, switches, and storage at data rates of up to 128 Gbps. And 128 Gbps is a lot of speed. It was developed to overcome the limitation of the small computer system interface, that is SCSI, and high performance parallel interface, that is HIPPI, by filling the needs for a reliable and scalable high throughput and low latency protocol interface. So this basically gives a lot of speed, that is high throughput, and it has very low latency and has lesser data loss. Fiber channel is especially suited for connecting servers to shared storage devices and interconnecting storage controllers and drives. The fiber channel interface was created for storage area networks, that is SANs. Fiber channel devices can be as far as 10 kilometers apart if multimodal optic fiber is used as the physical cable medium. Optic fiber is not required for shorter distances. Fiber channel can also work using coaxial cable and ordinary telephone twisted pair. So for longer length you need optical fiber cables, and for shorter ones you can just use coaxial or ordinary telephone twisted pair cables. Next we'll talk about fiber channel layers. Fiber channel defines layers of communication similar to but not different from the open system interconnection or OSI model. Like OSI, fiber channel splits the process of network communication into layers or groups or of related functions. OSI includes 7 layers, while fiber channel has 5 layers. IP networks use packets and fiber channels rely on frames to foster communication between nodes. The 5 layers of a fiber channel frame are upper layer protocol mapping, that is FC layer 4, common service layer, that is FC layer 3, signaling or framing layer, that is F layer 2, transmission layer, that is FC layer 1, and physical layer, that is layer 0. And here we have all the layers, and this is a fiber channel frame. So as you can see, there's FC 0, 1, 2, 3, 4, that is the 5 layers. And yeah, the FC3 is common service layer, and FC2 is framing protocol or flow control, and FC1 is encode and decode. Now we'll talk about fiber channel components. So fiber channel mainly has 4 components, that is switches, host bus adapters, ports, and software. Switches. A fiber channel switch enables a high availability, low latency, high performance, and lossless data transfer in a fiber channel fabric. It determines the origin and destination of data packets to send to the intended destinations. As a main component used in SAN, fiber channel switches can interconnect thousands of storage ports and servers. Features in fiber channel director class switches include zoning to block unwanted traffic and encryption. The HBAs, that is host bus adapters, are cards that connect servers to storage and network devices. A HBA is similar to in principle to an Ethernet network adapter. It offloads server processing of data storage tasks and improves server performance. When fiber channel and Ethernet networks first converged, HBA vendors deployed convergence network adapters, that is CNAs, and combined the functionality of fiber channel HBA with an Ethernet network interface card, that is NAC. And now let's talk about ports. Fiber channel switches and HBAs connect to each other and to several through physical or virtual ports, and to servers through physical or virtual ports. Data in a fiber channel fabric node is sent and received through ports that come in an assortment of logic configurations. Fiber channel switches can have fewer than 10 ports to hundreds of ports in a chassis. The connections between ports and HBAs are established using physical copper or optical cables. And the final component is software. Fiber channel installations depend on software layer for device drivers, along with the control and management between hosts, ports, and devices. Software offers a visualization of the fiber channel environment and enables oversight and control of fiber channel resources from a central console. So the software mainly controls where data is being transferred and the flow of data and everything that has regarding hardware. Next is the fiber channel design and configuration. The FCP supports three main topologies to link fiber channel ports together and enables devices such as switches and HBS to connect servers to a network and storage. So first is point-to-point. The simplest and most limited fiber channel topology connects two devices or ports together, such as linking a host server to a direct attached storage. The arbitrated loop. The devices are linked in a circular ring-like manner. Each node or device on the ring sends data to the next node, and the bandwidth is shared among all devices. If one device or port fails, all of them could be interrupted unless a fiber channel hub is used to connect multiple devices and bypass failed ports. Next is switched fabric. All devices in this topology connect and communicate via switches, which optimizes data paths using the fabric shortest path first routing protocol and lets multiple pairs of ports interconnect concurrently. Ports do not connect directly, but instead flow through switches. When one port fails, the operation of the other port should not be affected. All nodes in the fabric work simultaneously, increasing efficiency, while redundancy of paths between devices increases availability. Switches can be added to the fabric without taking the network down. And here we have a diagram of basic fiber channel SAN topologies. So first topology standalone, and there's only one switch required for that. There's a single switch that can scale vertically. And cascade is this requires minimum of two switches. Basic technique for scaling horizontally or to span locations with inter-switch links, that is ISLs. So we use ISLs between the switches. Then ring topology is used for horizontal scaling to increase port capacity, and a pair of rings with multiple ISLs could be used for redundancy and high performance. Core or edge tiered topology is it connects existing SAN islands, and various sized switches can be used for core and edge functions. Thank you. That is all for today. Please like, share, and subscribe.